All right, my name is Anja Joda. I'm a program manager on the Azure Stack team. And
Matt McGlynn, program manager on the Azure Stack team as well.
Now you can hear me a little bit better. Looks like we've got not too huge of a group today, so as long as you guys want to go for it, you can ask questions during this, and we can kind of make this a bit of a conversation as we go through some of the demos and stuff. So I'd rather tailor it to you guys since there's not a ton of you, and we have that ability. So if you guys have questions, you want to talk through something, go for it. Feel free to interrupt us.
all right, so let's go get started. First, before we get into the meat of the presentation, I just wanted to kind of gauge the audience here. How many of you are developers? Raise your hands. Okay. And how many of you are administrators? You run your company's infrastructure. All right, I saw one of you raise your hand twice. You have, okay, you have a, I wasn't seeing things. All right, and then how many of you all have done some research into what DevOps is? All right, cool. Great. All right, the majority of you. This will be good. All right, well then let's get started.
So we're going to start off with like a DevOps part first. We're going to kind of talk about DevOps and how it relates to Azure Stack. And then we're going to go through an application of that, like taking an edge application as kind of a case study to look at how you can use a DevOps pipeline to deploy applications at the edge with Azure Stack.
All right, and I forgot one more thing. How many of you all have deployed an Azure Stack development kit, our one-node system? Beautiful. All right, a good
there should be more of you out there, though. It's totally available, free, and you just need to meet the minimum hardware bar, but you don't need a special system for it. So, which yes, it is a minimum hardware bar, but so all right, give it a try.
So let's go ahead and get started. So first, we'll talk about what it means to have an edge device or to have edge compute, and then go through an example application that we think really emphasizes the power of an intelligent edge and an intelligent cloud. And we're going to go through some of the design principles we use to create this application. If you've been in any other Azure Stack sessions this week, you may have seen what they're called hybrid patterns, some building blocks to put an application that uses Azure and Azure Stack together. And then Matt's going to take you through the entire solution we put together. And I promise you it's going to get very in-depth. You signed up for a 4,000 level session, you're going to get a 4,000 level session. And then some things to keep in mind as you develop your own apps. So just what is the edge? Why do we want to use things at the edge, especially when it relates to Azure Stack? More often than not, the edge is thought of as a place where we do things that are too small to be dealt with in the public cloud, or there's too many things to be dealt with at the same time. Azure Stack kind of occupies a different niche. We think of Azure Stack use cases for the edge where you put the word limited in front of something, where you have limited connectivity. You know, you have intermittent connectivity, or you don't have any connectivity at all, and you need to do some processing wherever you are. So think of like a factory floor with that's not a data center. Or limited serviceability. You're on a ship. You can't really send an IT guy along. You can only look at the thing whenever it comes into port. It's limited scalability. Branch offices, place where there's not room for an entire server closet or a data center or a rack. Or limited data mobility, which is probably one of the more important ones, which is when there are regulations that prevent you from moving your data outside of its location. So think parts of the European Union. So we heard a use case from a customer in Canada who can't move his data out of the borders of Canada. That's where Azure Stack comes in handy. Azure Stack makes the perfect edge device in those situations because it has enough processing power and juice to do big data ingestion. It's great for low latency initial processing when you want to take and consistent development. So your company already has investments in the cloud. They know, your developers know how to use it. And they want to apply that to something that's local rather than in the public cloud because they're restricted in some way. It's an integrated system. You know, if you've attended some of the Azure Stack servicing sessions, they talk about how you call the hardware vendor or Microsoft for support, and then we work together to resolve the issue. We handle things like fault replacement and software issues. And it's, of course, a dense hyper-converged infrastructure, and it's auditable and compliant with several different regulations. Azure Stack really shines when you use it as part of our hybrid cloud consistency program, which, along with our common identity, our management, and our data platform, you have a unified development environment that uses the same APIs, authentication system, and development tools. Here's a customer scenario that kind of highlights this. So Avid Media Company, Avid Media Productions, they make professional editing bays, and they handle a lot of the video compression and movement for news stations and movie houses all over the world. And news reporters are often embedded in areas that have limited connectivity. They have to use satellite uplinks, and latency is an issue trying to get their feeds back to the central network control station as fast as possible. Now, they've used Azure Stack and Azure to send video to Azure Media Services in the public cloud to run cognitive analysis, and then render those videos on Azure Stack for playback on local news stations or local areas. This is made possible because their developers were already using Azure Media Services in the cloud and realized that they could use Azure Stack because they already knew how to use Azure itself. And it made moving that much easier rather than having to stand up their own development stack and APIs to be able to deploy these applications consistently. So some of the design principles that we kind of want to go through and we want you to be thinking about when you wonder, does Azure Stack belong at the edge, are these things. Local secrets. You have some secrets that exist. You want to maintain some secrets on premises and have them used to unlock things in the cloud. We have Azure Key Vault on premises. Staged data analytics, which is what we'll be really digging into today, is if you have a lot of data being processed in a location and you want to do some sort of base processing and only send what needs to be sent to the public cloud for archival or further analysis. Azure is a secure edge to have Azure Security Center and Traffic Manager filter your traffic, make sure that it's safe before it goes to your data center. Geo-distributed applications, where if there are geographies that do not have access to an Azure data center right now, you can put an Azure Stack there, and Traffic Manager will automatically find the best endpoint to send it to. Cloud growth, also formerly known as cloud bursting, where during peaks of seasonal demand or high demand, Azure Stack, when there's a restriction to have company information on premises, Azure Stack can be used to service regular demand, and then when demand becomes too great, it can then activate instances in Azure that give it the ability to process more requests. And of course, data sovereignty, when data absolutely has to be within a certain border, country, or region. The foundational patterns, the patterns that make all of those things I described possible, are that we have hybrid connectivity. Either your Azure Stack is deployed on the public internet, and you can talk to it just the way you would public Azure, or you have a site-to-site VPN set up through ExpressRoute or some other means, or you work with a data center provider to make sure that Azure and Azure Stack can talk to each other. A hybrid continuous integration and continuous deployment. This is the core of DevOps, and we've worked really hard over the past year to make sure that Visual Studio Team Services and Visual Studio itself integrates really well and provides a smooth deployment pipeline for both Azure and Azure Stack instances as part of one overarching workflow. And of course, hybrid identity, that the credentials that I use for my private cloud are the same credentials I use for my public cloud. And if I want to have different credentials, I can do that too. We both support Azure Active Directory and ADFS for authentication. Let's just dig a little deeper here. We've done a lot of customer research around these different patterns. And again, hybrid connectivity, that customers really want to have connectivity between resources in their on-premises environment and a public cloud, and that we make that possible. That there's a hybrid CI/CD pipeline that developers can use the same DevOps skills they've already learned or that you're already researching and apply them across both public and private cloud. There's no need to learn two different stacks for two different data centers. They can just treat it as one big one. And here's where it gets a little bit more fun, staged data analytics. We have data that's low level, or in our case, camera data, that needs to be analyzed, filtered out, and then sent on for further analysis. These are just diagrams just so you can kind of think about it and think about how this might apply to use cases in your own organization. And of course, how does DevOps work with Azure and Azure Stack? The big improvement here is that your application infrastructure can be defined as code in both places, both in Azure through the use of ARM templates and in Azure Stack, also through the use of ARM templates. That you can deploy over and over again, rather than filing a ticket and saying, hey, I need an environment to do this. I need a virtual machine that does that. I need the credentials to install my software. IT manages the infrastructure itself, that Azure Stack is up and running. And then developers can deploy as they will, as long as they don't go past their quotas. I mean, how many times have you guys heard, oh, it worked on my box when the latest update goes down? Really? Not that many people? All right, you guys are good. You heard it from me. That's cold, man. Why you gotta do that? But I mean, he's not wrong. But I mean, that's the thing. This way, everybody who's trying to develop this application is deploying to the same hardware, and they get the same standardized environment over and over again. And this, again, works both in Azure and Azure Stack. I don't know how many of you saw the keynote today, the keynote on Monday with Scott Guthrie's presentation, where Donovan Brown came up, and he's really kind of our DevOps guy. He said, DevOps is people, processes, and products that work to enable delivery of new features, of value. And it's really a culture shift, that rather than saying, oh, I finished my application package, let's chuck it over the wall at that guy, that you have one team and you're all responsible for the same thing. You're all responsible for a feature making it to the customer, and that feature works, and that you're able to respond to failures and you're able to respond to incidents quickly. It's actually kind of how we develop Azure Stack. We have a lot of the same processes that I'm talking about built into our own labs. Again, it's on a much larger scale because the product is so huge, but we do the same things. And so we've put a lot of effort into making sure that this works for everybody. And of course, the end goal is that everything is completely automated. Here's just a quick list of DevOps practices. We'll only focus on a couple today. The big one, the one that really works with Azure and Azure Stack, is infrastructure as code. When ARM, and we'll go through this in a little bit, that when you see ARM templates are almost exactly like code. They can be checked in, they can be versioned, they can be rolled back, they can be automatically deployed and tested. Life becomes a lot easier. Continuous integration, that not only can you continuously test code, you can continually test your infrastructure as code to make sure that it's up and running at any given time, or that the latest update you push to, say, add a load balancer didn't fail and accidentally lock out your entire web application. Automated testing, again, of both code and infrastructure. Continuous deployment, that as soon as new features pass those automated tests, they're out to the world. That way customers can start using them and you can start getting rapid feedback. Release management, that you know what your customers have and that they don't have something to test, build, or anything. And of course, performance monitoring and configuration management to make sure that all of your hardware and all of your virtual hardware runs the same way. Continuous integration, it's fairly simple. You really want to say your accelerated delivery. Features get out the door faster. That you can do the same thing every time. Again, we're getting rid of, it worked on my box. Oh, it worked last night. And that whenever you say, I want to deploy this, it'll work on any environment, public or private cloud. That you're making use of all the resources that your organization has. That you're not saying, I need this hardware, and it is my hardware, and it is my special hardware. And that you are saying, this is my commodity hardware. I'm just going to use some of it for a little bit, and then I'll give it back to the next guy who needs it. Because I know that the second time I need to test it, I will get the exact same thing the next time. And you can measure whether or not these things are having an effect in your organization with more frequent releases, and your mean time to respond to failures, and your mean time to complete a deployment, MTTR and MTTD. Continuous deployment, once you've gotten past continuous integration, that all your builds work correctly, all the tests completed. There we go. Software, of course, goes to a QA environment. Again, this is all automatic, and that you're still making use of that same hardware. The same hardware that you did your build on and your initial tests on, you can wipe it clean and use it for your continuous deployment and your QA. That way, again, you're not having to acquire, this is my QA rack, this is my production rack, and oh no, there are 3 different generations of hardware because that's when we got the purchase orders to buy them. Again, the way you can tell whether or not this works in your organization is that your deployment rate is faster, you have a better mean time to respond to failures or incidents, and that your application is up more, your availability. The real fun is infrastructure as code. Again, ARM templates that can be automated and versioned just like regular code. All those concepts I just talked about, it's the same thing, but just with JSON instead of C++, C#, Python, PHP, and so on. You're making the best use of your resources. If something's cheaper to run in the public cloud, you can run it there for your dev test and run it in production on Azure Stack because you have a requirement for an edge case. You can measure it because you have a faster deployment rate and you have a faster time to resolution. Automated testing of hardware is, again, this is probably one of the more important points of DevOps. If you have everything else automated and you're getting garbage off the end of the build cycle, then you've automated failure to your customers. Don't do that. Make sure that you're testing everything in the middle, that whatever you're putting out to your customers has value, and that the only incidents you're getting that wake you up at 2 in the morning are the actual show-stopping incidents. So just to show you how we've worked with the Visual Studio's team to integrate Azure Stack into our DevOps process, I'm going to run through a very quick demo here. I'm on 7. So this is Northwind Insurance. It's a VSTS application. I'll show you what it looks like. It's very simple. It's simple. It's an insurance application. It's an ASP.NET web app. You'll see in the top there's a blue bar that says this page is loaded from Azure Stack. This is originally used as part of a demo for cloud growth, but we're just going to make a simple change here because this is running on Azure Stack and not Azure. So I have this. I'm going to change that bar to be red. Okay, hello. Add it in. Commit. Oh, wait. There, red. Save it. Changed bar color. Commit. At this point, Visual Studio is going to kick off a release pipeline that includes both Azure and Azure Stack. It's building it. It's going to take a little bit of time here. But while that's happening, let's look at our deployment strategy. Releases. So again, deploy application, release definition. Edit that. And you'll notice I have 2 environments, one Azure Stack and one Azure. We're not even using anything hybrid identity here. This is run by a Visual Studio Team Services agent running on each cloud. And you'll see it just uses IIS management to deploy the web app and restart it. This is, again, on Azure Stack. Let's go back. And of course, on Azure, it's identical. All I had to do was copy-paste, and I have the same consistent deployment experience. I didn't have to learn something different. I didn't have to worry about idiosyncrasies between environments. I just copy-pasted. Let me see if it's done yet. I don't think it is. Oh, absolutely not. That would make sense. Results. All right, well, that goes on. We will.
Nothing like getting to see some NuGet packages getting restored, right? It's kind of exciting.
Yeah, right. So while that goes on, we will go ahead and run through our example application that we've built. So today we're going to take a deep dive into a company we call Contoso Property Management. They manage several different corporate locations. Oh, I'm not switched back. Contoso Property Management. They run property they manage the properties of several different corporate locations in the area. And as such, they really want to know if anything suspicious is happening on the security feeds. and they don't really want to keep a security guard roaming the place at 2 in the morning. So what they've decided to do is to have all of their cameras dump video back to an Azure Stack and leverage their existing cloud improvements with recognition of people and automobiles to develop an edge-based application that ingests the data on premises to an Azure Stack using Azure and Azure APIs. Again, there's not an Azure Stack API. It's just the Azure APIs. And uses a machine learning model that we've worked with and developed in Azure using the power of Azure. They have those GPU-enabled virtual machines. They have extra compute power. And then we've turned that into a model that can be rapidly deployed at each site, infrastructure and all. So that way, the developers at Contoso Property Management are able to leverage their existing cloud investment of their training virtual machine in Azure and their skills of how to develop for Azure and work with the Azure application model. And of course, this is all compliant with corporate policy because personally identifiable video is not being broadcast over the internet, and they're able to save money because they don't have to run high bandwidth lines to each of their property locations to deal with all of this video being streamed to Azure. And let me go ahead and see if this thing is done. No, just see. Still running. Okay, it's releasing. It's just, okay, all right. Well, that's working. We'll go ahead and go into our scenario architecture. First, we start off with a blank resource group in Azure, a blank subscription, and a blank Azure Stack. Nothing's on it but Azure Stack's compute, network, and storage resource providers, along with Azure App Service, which includes functions. In order to be able to talk to both of these clouds, we have to add a bridge, which turns out to be Visual Studio Team Services. The reason we want to use Visual Studio Team Services for this is that it has a lot of tooling, such as agents that can run on each cloud to make sure that instructions and we can run scripts. So for example, we have to update a Docker container. We just have that agent run an SSH script to manually move things around.
One thing to note about agents is like a lot of times when you deploy Azure Stacks, they're not going to be exposed to the internet. And if they were exposed to the internet, it's super easy, right? Because you just hit the ARM endpoint. It's just like hitting Azure. So your VSTS could go directly against that Azure Stack deployment. But in the case of Azure Stacks, which are routinely deployed behind NATs in an actual environment, the agent allows you to kind of have a pull-based model. So the agent can always get out to the internet and retrieve the artifact. So for Azure Stack, it's quite handy to have these VSTS agents.
Again, Azure Stack compatibility, the agent can be installed anywhere. There's a script available on Visual Studio. You just copy paste it, it'll work. Build and release automation across both clouds. And of course, Visual Studio Team Services makes for great source control. And now, they just released this, that they have connectivity to both Azure and Azure Stack using the native Azure template deployment functions. And I'll go ahead and show you how we go about enabling that.
You're in mine.
So right now, actually the other thing is finished. Northwind Insurance. Or not. Okay, we'll just move on. So setting up a hybrid infrastructure, this is the current release pipeline for the Edge application we built. It's just got an Azure Stack with 3 tasks. In order for us to be able to talk to Azure Stack, we have to set up a new service endpoint here. We had an Azure Resource Manager, Azure Stack 2.
Full dialog.
Full dialog, right. We want to tell it to go to Azure Stack, which allows us to have more manual control over the environment. And I have all my little helpful snippets here. You enter the management endpoint for Azure Stack, subscription ID, subscription name, and of course you'll need to create a service principal in Azure Active Directory. That's kind of what makes the magic happen. Because you have consistent authentication and identity between both clouds, whatever you do in Azure Active Directory in Azure, you can extend to Azure Stack. So I have a service principal ID.
So pretend you forgot the service principal password. We'll have to change that after this session.
Yeah, I know you all are taking pictures of it. Go on. I promise I don't have that much spend enabled. And we'll just paste that. I can't verify it because this is a one-node system, so it's inherently not on the internet. But if your one node was deployed on the internet, or your multi-node system was deployed on the internet, you could absolutely hit verify connection and test your endpoints and make sure everything worked. After this, I can now just go to my releases. Create a release definition. And I could honestly check, search for Azure. Or let's just start with an empty process. Azure Stack. Okay, let's add an environment here. And then I can see it's already given me the option to add an agent. And then because the agent is deployed inside Azure Stack, I can use all these really cool native functions, like say Azure Resource Group deployment. And instead of having to only select an Azure subscription, I could just tell it to use Azure Stack. So is it Azure Stack 2? Create update resource group, and then I could just enter my information, and away I'd go. We are going to show you the completed results of our first one, just because we don't want to accidentally overwrite anything.
Open it in private, probably, for Northwind.
For which Northwind is, yeah, okay. Nope, it's still not working. All right.
Oh, well.
Oh, well. So after this, after we've got Visual Studio Team Services enabled, we have a template that deploys our entire infrastructure. Because the application is containerized, we use Docker Swarm along with a couple of Azure functions and storage accounts to hold all of our data. Let me go ahead and bring back the diagram. Right. So as you can see, a Docker Swarm is the infrastructure templates are checked into Visual Studio Team Services just like regular code. The Docker Swarm is deployed and coupled with some functions and storage accounts to shuttle around the data. So I have those templates here. And as you can see, here's what deploys a Docker Swarm. This is actually available on the GitHub Quick Start, and you can try it today. So Azure Stack Quick Start templates, we have a GitHub repository where we keep all of these things so that way you can get familiar. And one of the more interesting things, we deploy a number of virtual machines along with a couple of network interfaces because a Docker Swarm has a master node and several worker nodes. And then we have a jump box that we use to connect to it. And we, of course, deploy a master virtual machine. It's, again, just like you would in Azure. You get a disk, and then we also deploy a VM, a number of virtual machines for agent nodes. And we have a couple of, and the more interesting part, the thing that makes all the magic happen, that takes it from a bunch of VMs and a resource group to a Docker Swarm instance, is these virtual machine extensions. That we have scripts that are pre-made that you can use that turn it into, that set up the Docker Swarm, set up the networking, and then prep all of the instances and network them together and wire them all together. To set up the functions, we also have another ARM template. Again, what you can do is that you can send an Azure Stack to a place where there is no connectivity. You can send somebody with these templates and a script on a flash drive, and they could easily lay down the entire infrastructure that we're talking about today within a few hours. So we've got these settings that tell us which storage accounts to connect to for the Azure, for the function. And then we can change these based on different variables depending on which location we're talking about. And we've got different, and see these default endpoints here allow us to talk to different instances. So when you redeployed an Azure Stack using a different domain name than the defaults, you can easily change it here. You can change it through a configuration file. And again, it's just as easy to stand up as it would an app in Azure. And once we've got that infrastructure laid down, Matt's going to take you through how we actually enable the machine learning part. Matt, do you want to take over?
Yep. OK. Cool. So now we get to kind of the fun part. So just keep in mind a lot of the stuff that you've learned from Andre, right? Like he's gone through some of the foundational elements of setting up a DevOps type pipeline with VSTS. We're going to kind of take that and we're going to actually kind of deploy this edge-based application. And he took a look at the ARM templates we use for this. It is good to note that Azure Stacks tend to have different DNS suffixes, right? Like it's in a customer environment, it's your DNS suffix. So one thing to make sure of is when you're going through connection strings, all that stuff, make sure you check the DNS suffix of the connection string and make sure you try not to hard code that as much as possible. That way, when you flip between Azure and Azure Stack, you can keep that same template, right? Like that's the whole point. Cool. So right here, let's see, let's go through all this whole thing at once here. So essentially, at the edge, we're kind of suggesting a scenario in which the company is actually ingesting data through cameras. In this case, we're kind of simulating the cameras as if they were IP cameras, right? We're grabbing frames from them. And this allows us to load up a storage account with those images. So we're going to use a function that reaches out to our camera, which is supposed to be an IP camera in this case, but in general, we kind of mock it for this example. It would pull the frames from that IP camera and then put it into the storage account. So we're loading up images into this storage account. We call this kind of the scoring queue storage account. And then we have a Docker Swarm cluster running on our Azure Stack. One of the cool things about Azure Stack at the edge that is a little bit different than other edge devices you can think of is we actually do have, it's a system that can survive a node failure, right? A lot of edge devices, they may just be kind of a one host kind of deal. And one of the cool things is with Azure Stack, we can actually tolerate a node failure. So things like a Docker Swarm cluster can actually land on top of Azure Stack and have that resiliency, right? So it's just a kind of a key aspect of what kind of differentiates Azure Stack at the edge. It's something that I think will really help us be able to bring some more highly available type applications to it. At this time, however, we are still kind of restricted with one fault domain. You'll see shortly after GA, we're going to add support for additional fault domains. Then, after we've kind of laid down that Docker Swarm, we put our container on there. So that container is the real magic of the model that scores the images that we've had coming into that storage account and then puts the results onto another storage account. And this other storage account kind of allows us to differentiate between interesting and whatever images, right? Specifically, imagine if you had limited bandwidth in this scenario, right? And you can't actually afford to send every single frame of this camera footage you're collecting up to the cloud. So you're kind of choosing the images that are interesting enough for you to send back up to the cloud. So what we're really doing is limiting that bandwidth all the way back. And then to send it up to the cloud, we have a function that will periodically run on a schedule. So if you guys are familiar with functions, there's a couple ways you can trigger them. Well, there's actually a ton of ways you can trigger them, but the two we'll go into today, HTTP REST-based triggers. So just for our camera thing, I just did a REST-based trigger so we can just fire it off when we do the demo. For the other one, though, it's a schedule-based thing. So it runs every 20 seconds. It's like, hey, what do we got in this positive storage account? Let's go ahead and replicate that up to our Azure forwarding storage account. If there's a loss of connectivity, that function will fail. It's all right. It'll start again in 20 seconds to try it again. So if you can imagine an edge scenario where the connectivity is actually intermittent, you can still replicate that data back up to Azure by just running this function. It's not terribly exciting, but it allows you to kind of take the data that you're interested in, get it to Azure, and handle both a low bandwidth situation and an intermittent connectivity situation. And then in the middle, we've got this training VM and ML model. So we'll kind of go through that part as kind of an advanced use case. But let's get started with just a basic use case. So if you guys are familiar with OpenCV, has anyone used OpenCV before? A couple of you. OK, cool. So they have a built-in classifier not really a classifier, it's actually more of an object detector, and it's using something called a histogram of gradients. And what it does essentially is we're going to look for pedestrians, and it will take an image, and it will look for pedestrians in the image and then kind of put boxes around them. And so that will be the heart of our container that we have deployed on this Docker Swarm. So before we go through the whole pipeline, we're just going to start by putting an image through and then seeing it kind of come out the other side. Alrighty, what am I? I'm 8. All right, let's see if our connectivity is still all good. Okay, looks like we still got connectivity. Okay, cool. So the first thing we'll take a look at is the camera function. So remember how I was saying that the camera feed is coming in via an IP camera. We're going to take frames and we're going to put it into a storage account. Again, all on Azure Stack, right? So you'll see some of the interesting differences of Azure Stack. I promise I won't dive into too much code today, but here you get a little bit. So here's kind of looking at what our camera function is. So really what we do is we ingest the connection strings from that app settings of the functions application. So you guys remember that ARM template that Andre was showing you? It had in one of those sections the connection strings that we're providing as part of that template deployment because the storage accounts are also laid down, right? So there's a dependency on the function for the storage accounts to be laid down first so we can know where to direct the function to send the output data, right? And so one of the cool things is, yeah, we just ingest this as an environment variable into our function, which is really just a C# script, if you will. And we'll take frames that are available in a storage account kind of to emulate the IP camera, and then we'll go ahead and drop them off into the input to the scoring piece, right? And we'll run this a number of times. I think I've got it set to 100 right now. So we'll go ahead and throw 100 images through this pipeline now. Okay, so images are already starting to flow through. You can kind of see in the logs all those images. These are just URIs that we're cranking through. Let's take a look at it from the perspective of the storage account. So if we go into the scoring bucket, so this is the storage account that will hold the data that has not yet been scored but is prepared to be scored by the container. One thing to note, I am actually over triple VPN right now, so things will load a little bit slow from the perspective of the UI. If this stays for too much longer, we'll switch, but here we go. So like here, we essentially take the frame, load it up as kind of just a GUID image, and stick it on the pipeline. So some of these will be, so we have like 2 images in this thing right now. It's kind of cars and then like a group of people. And so one is negative, right? There's no people in the cars picture. And then there's also people in the people's picture. So we can grab one of these and this will show essentially pre-scoring. So let's see which one we get. So that's the car. Let's see if I can get one more. That's the other one, just so you guys see it. All right, there we go. So this is the image that we'll hopefully try to find some pedestrians on. Right now they're crossing the street, so hopefully we can identify some of them. So now let's take a look. Again, we're on Azure Stack right now. You can see in the corner, if you guys have never used Azure Stack before, it's kind of like Azure, except look, there's a little stack at the end. We'll go ahead and take a look at the other storage account. Let me back out of here. Okay, and here we have both a positive and a negative account. Remember how I was saying we're trying to only send part of the data up to Azure. So in the negative account, if we take a look right now, because we're looking for people, we'll find cars. So like there's my car. Cool. So now if we go into the positive account here, we'll see people and the kind of the result of the scoring functionality. Okay, cool. So like it mostly gets people. Turns out archways look a little bit like people, so we've got a couple of those too. Maybe that's why people like them in buildings, right? But essentially, we are picking out the people in the image, we're identifying them, and we're putting them to that positive storage account. That's the storage account of the data we actually care about. So now let's talk about how that edge data gets back up, right? So if we go back into our function application, we also have this forward results function. And if we monitor it, what we'll see is a series of invocations of that function. Let's see here. This will take a second to load. But while this loads, we can take a look at the code here. So again, nothing terribly exciting, but timer trigger, so every 20 seconds in app service functions, super easy to trigger these things a number of ways. And we're just happening to use the timer. Again, we set up essentially blob storage account clients with our connection strings that we've gotten from our Azure Stack storage accounts. And one of the cool things that you'll notice with connection strings, if you guys have used them, is they actually do contain that default endpoint suffix at the end, which is kind of nice because in Azure Stack, who knows what it's going to be, right? In Azure, it's obviously usually core.windows, or sorry, what was it, blob.core.windows.net. Yeah, so in Azure Stack, in this case, it's like Azure Stack.local or local.azurestack.external, right, for our specific Azure Stack. But it could be anything. It could be your corporate DNS suffix. So again, nothing terribly exciting here, but we look for the blobs that are in that positive storage account, and we send them up to Azure. So let's go take a look at Azure. Oh, and just to show you the invocation, so it runs a bunch, right, because it's running every 20 seconds. And every time, like sometimes you can see some of these bigger duration ones are where it actually finds stuff to send up. Other times it doesn't really find anything, right, because everything's already synced. So now if we go to Azure, we can take a look. Here's our positive account up in Azure. And these images just came in. Look, 11:53, all live, I promise. You guys get to see a truly live demo. And so we take a look at that same image. And of course, as you would expect, it's the people again with the identification and throwback to MS Paint. So you can see both. But yeah, so at that point, the replications occurred. Now the data is up in Azure. And so really this is about for applications where that data is coming in at a large clip, right? We could have lots of cameras. With Azure Stack, if you get an appropriate hardware SKU, you can actually handle a lot of these transactions, right? And that's kind of exciting for an edge-based application where usually the edge device has like no actual compute capability. You're like doing barely anything on it. You can actually do a little bit more with an Azure Stack appliance at the edge. OK, cool. So let's talk a little bit about, remember how we had that Azure training VM that I was talking about? So that's how we can take your business-specific model and apply it to this pipeline. So right now, we're just taking a general model of identifying pedestrians. Let's say we trained something that was a little bit more tailored to your company's application. In Azure, if you guys are familiar with the data science VM, we'll take a look at one of those.
Quick question. Who here has used the data science VM in Azure?
Probably didn't think I was going to go into too much data science today, did you? But we're going to go into a little bit, just enough so we can kind of talk through what an interesting application would look like at the edge that's kind of more realistic than just identifying people. So we got a couple ones here, but specifically we're going to use the N-series one. Is anyone familiar with the N-series VM size in Azure? OK, so the cool, fun thing about N-series VMs is they have a graphics card in them. And graphics cards are one way to really accelerate production of training of models, right? And how they do that is really about parallelization, right? They're able to handle extremely large matrix multiplications very quickly. And CPUs can do it, but they don't do it at quite the clip that GPUs can. And when you're training a model, you're not just ingesting the live feed. You're actually also going back through over and over again to do something called backpropagation, which is taking the errors you got from your initial runs and then propagating that back into the model so you correct it so it gets better the next time. And so when you're doing that, you're cycling through data again and again and again. And you also have a ton of data, right? Because sometimes people will learn on hundreds of thousands of images, which is not going to be the same requirements as the ingestion. So the fundamental divide you're looking at here is using Azure Stack at the edge, you can actually do the inference there and the training in Azure. Because at this time, Azure Stack does not yet have GPU capability. It's something we do get questions about from time to time. We have nothing to announce just yet on that. But today, Azure Stack does not have GPU. So it makes a lot more sense to do your training in Azure where you have that GPU compute capability and bring that trained model down to Azure Stack where you can keep up with the data as it comes in. All right, so N-series VMs, we've got our GPU. This thing's pretty expensive, but it's really awesome. Cool. So we're going to take a look at a little bit of a lab. I promise I won't dig us through this too much, but there's a data set called CFAR10, and it really is essentially just a classification problem of 10 different types of images: airplanes, automobiles, birds, cats, deers, and there's a bunch of stuff. But it's just kind of a simple case where you've got an idea of the image you're looking for. So if you can imagine a factory floor scenario, if it's looking for a certain defect in a product, and you have a bunch of sample images of what that defect looks like, then all of a sudden using that sample images to generate a classifier based on them could be really effective. So in Azure, we can kind of run through this by just kind of going from each of the layers. I don't know if anyone used Jupyter Notebook before. It's a great tool for just kind of using Python as kind of like you run a little bit. You can write some of the README parts and explain what you're doing, run a little bit again, and make sure you can explain everything as opposed to just kind of having a blind script where you're kind of forced to rely on comments. So one of the tricks that takes place in these neural nets is something called convolution. But essentially what we're doing is, because images tend to be somewhat homogeneous across their features, we can actually take samples of them and move across the image, and that will generate kind of features that we train on. So in Azure, we're looking for these features, right? We've got this image that we're trying to classify against, and we're trying to find the features in that image, and then take that features, extract them into a model, and bring them back to Azure Stack. So we won't go too far into this, but one other piece that we do use is pooling, which allows us to kind of downsample the images. So the images, when you train them, even in the most advanced, with the most advanced GPUs in the world, they're not huge, right? You end up downsampling them to like resolutions of like 200 by 200 or something crazy like that. In this case today, we're actually only doing 32 by 32. But as you kind of go through the problem, you start to downsample each of the nodes. That way you take some of the complexity out of the neural network. And why is that important? Because when you move that neural network and when you train it, it's quite large and it occupies a ton of memory. The whole model has to be loaded into memory, whether that be GPU memory or CPU memory. And some of these bigger models can take a lot of room, like over 5 gigs if you want to do something huge, right? So just something to keep in mind. Let's see if we can get to the training part here. Yeah, here's a fun one. Okay, so for live demo's sake, this thing will actually train right now in Azure. So we're using that GPU to really accelerate this thing, and it'll actually go fairly quick. As it trains, it gets better, right? Like initially the model is pretty terrible, but over time, as it does the back propagation where it's correcting the errors in the model, it gets better and better. Right now we're using a library called CNTK, if you guys are familiar with that. That's the Microsoft library for kind of defining some of these neural networks. It does some other things as well, but one thing it does really well is defining the neural network that you're actually training on. You kind of tell it how this thing is going to go from the evaluation perspective, and it will handle all the training parts, so like the back propagation pieces. But as you can see, over time, we get lower loss in our training. Okay, cool. So enough data science for now. If we move back into Azure Stack, we can take a look at how we can actually use this model. So here in Azure Stack, this is the script we are doing for just doing pedestrian recognition. We're essentially packaging this up as a container and then adding it to the Azure Container Registry and then pulling it down to be deployed on top of that Docker Swarm piece, right? And this application right now, all it does again is just do that HOG classifier, histogram of gradients, and identify pedestrians. So I think it's right here. This is all built into OpenCV. So we're just looking for pedestrians in this case. So now if we move over to a newer model, sorry. Okay. So this is the one that would be using a CNTK model. So in this case, I've already taken a pre-trained model. I've brought it down into the source code, and we actually can keep that with us. That way, when we deploy into the container, we have access to our now trained model. So you've got that N-series VM, you finish up your training, you grab the model, and you put it into your DevOps pipeline, and then you deploy it again. So in this case, we can actually see whether or not there was a car. So remember how we had two images, one's a car, one's a bunch of people? This time let's go ahead and identify the car. So I'm just gonna debug it locally here, just so you guys can get a glimpse of what this is like. So we'll start with debugging. I don't think I have any other breakpoints, so that should be fine. Great, so right now it sees no images in the queue because we've already learned on all of them. We go back to our function and we start up again, which allows us to put a bunch of images in the queue, just like we did before. So now tons of images are coming in. One of them eventually will be a car, I promise. And so we go back here and now we're at our debugged breakpoint. So in the CFAR 10, remember how there was 10 classes? One of that classes is a car, right? And the index of that class happens to be 1, so I've got that here. And if we take a look at this model running locally, just to kind of test it, you can see that the local image is indeed a car. So it's pulling out the fact that there's a car coming through the feed, identifying it, and just like the other one, you could then put that car onto the positive identified storage account and then replicate that back to Azure. So again, you're trying to pick out the parts that are interesting to you and your business and bring that from the edge to Azure as needed in an intermittent connectivity scenario. So thank you for bearing with me on that front. One of the other things we can do back in Visual Studio is scale it. So we have one of these commands that all it does kind of updates our image. Currently we're using this replica count. Because we have this Docker Swarm cluster on our Azure Stack, in this case, I think we've got 6 nodes.
6 is about right.
6 nodes on the Azure Stack, 6 VMs. And we've got plenty of room for containers. So we can go ahead and actually kick through the whole release pipeline by just updating that. So I think I have 15 right now. Now we've got 30. So we can kind of scale the training of the model. So let's just save. Since we're using the same build, we don't really need to go through the build pipeline again. But we can go ahead and create a release. And now what this will do is now my container that I've trained with the model will be spread across 30 replicas. Actually, in this case, it's the pedestrian recognition one. But if we go to the builds real quick, just so you can see this last piece. Edit the definition here. We take a look at the build definition. If it loads. Come on.
So while Matt.
It's all right. What we're really going for, though, is the build definition does a few things. It does the build of the Docker file. So we had that Docker file locally. I don't know why it's still going to this page. Edit. There we go. Thank you. OK, cool. So it grabs our sources. So remember, we have this CI/CD pipeline. We've got our stuff checked into source code, including the deployment templates. And we can grab the sources. From there, we have a Docker file in there to kind of take that Python script you saw and then containerize it, right? Ingest that Python script, build a container around it, and then actually chuck it up to the Azure Container Registry. So one of the cool things about VSTS is there's so many integration points. One of them is just obviously to Azure, right? So we've got our Azure Container Registry. I can pull it down by default from my Azure subscription. So we're using this subscription, and there is my Azure Container Registry. And then we push the image. So we essentially just add it up there, and then we publish the deployment template. Why do we do that? We take the deployment template through to the deployment steps, right? So as part of this build process, we need to make sure we have those templates in that release step where we can access the ARM JSON and then deploy it with the agent locally.
How many of you are familiar with Docker containers? Okay. All right, do you want to walk through the Docker file and show them how?
Sure, we can take a quick look through one of the Docker files. This is kind of a simpler one, actually, in this case. In this case, we're taking a base container that's Python, and we're throwing on top of the Azure Python SDK, and specifically the storage one. We're also doing a scikit image, which is just allows us to do some image resizing operations, and then OpenCV Python. So it's not terribly complex, right? Like it's just taking the script in, and it's installing the dependencies, the Python level dependencies that we need to run the script. So I'm not a huge expert on containerizing. I think there's a lot of other folks that can give you a better example, but it is something that like having the Swarm cluster on Azure Stack allows you to deploy these containers in a way that's kind of scalable across multiple nodes, which is kind of neat, even at the edge, right? I think that's all for the demo portion. Andre, if you want to finish this up.
Yeah, absolutely. Let's go back to the deck. So Matt kind of went through this while he was busy melting with. Now that Matt has melted your brains with data science for a little bit, we'll go ahead and talk about some of the struggles we faced while developing this app. There we go. So again, we deployed the model to the Docker Swarm. Then we were able to scale it out, and then sort it into 2 buckets, positive and negative. It's fairly simple. Does it contain the thing we're looking for? And then we enabled rapid scoring that when Matt scaled it out, which allowed for us to, what was the rate you were processing images at?
I think we can do about 500 a minute or so, but then scaling it out, I don't know, we could probably do quite a bit more.
Right, so that's pretty hefty for something that's designed to recognize images from a very large number of sources.
This is also a 1 node, so this is a 1 node Azure Stack in this case.
Of course, we again simulated the cameras because we thought it'd be a little creepy to use actual cameras. So we added that. We rapid data ingestion using the function. So you already walked through the functions. So yeah. And of course, when we were building this app, designing for the edge, you have to take some things into consideration. And these are just some kind of points so that, again, when you are designing these apps in your head, when you are looking at, do I want to begin an edge use case? Do I want to deploy Azure Stack at the edge? You get it right the first time. We want you to be successful. So we'll give you some tips. First of all, hybrid connectivity. Can Azure and Azure Stack talk to each other? It's fairly important. So first, your domain names. Most Azure Stack one-node systems, which is what this demo was built on, are deployed to a simple default local.azurestack.external. It's self-contained within the stamp. However, when you receive an actual production 4 node, you'll work with your hardware vendor to choose your domain names and anything else you need to customize your deployment. So you want to make sure that's routable from across the internet if you so choose. Again, firewall configuration. We actually have some Azure Stack's instances hosted with our friends at Rackspace, and we have to kind of email them and say, hey, can you open this port? We need to let this thing through. So it's important to get that right. Site-to-site VPN. You want to be able to configure site-to-site VPN between Azure and Azure Stack using a local network, a virtual gateway. So in Azure, you'll need a local network gateway, a virtual network gateway, and a connection to tie them together. And you'll do the exact same thing in Azure Stack, because again, Azure Stack is Azure. And then you'll have a site-to-site VPN, and then you can join 2 VNets. Cloud resource polling. As Matt said, we might have intermittent connectivity, his function that's scheduled to run every 20 seconds. What we would do is we would have it check to make sure that, yes, I do have internet access before I try to shove this data up into the cloud, and then continue retrying if connection or the bandwidth wasn't present. Again, connection checking, making sure that you do have a connection from the edge to the intelligent cloud. For your developers, some special considerations here. That you have special ARM templates. As Matt has been talking about, the default endpoint suffix, that you're able to talk to your storage accounts, that you're not relying on things that you might not have near that Azure Stack. If your Azure Stack is disconnected, you can't really get your scripts from GitHub or Visual Studio. It's not going to really work. Hard-coded deployment endpoints. Again, I talked about those domain names. Assuming content exists. This is a big one. So in Azure Stack, we have something called syndication. Has anybody heard of that? Marketplace syndication? Cool, that guy in the back. Awesome. All right, sweet. So what we do is we're working with all of our partners across the breadth and depth of Azure to deliver and say, hey, can our customers download your marketplace items and make them available to their tenants in their private cloud? And so right now we have, I don't know how many, 50, 100?
I think it's over
Over 200?
over 100 now. I
It's
don't know.
quite a
exactly.
large number, and it includes most of the most used templates and most of the most used solutions in Azure. So things like Windows Server, a large number of Linux-based stacks, and you want to make sure that these are going to be available to the Azure Stack you're deploying to. It's not going to really work if you ask for Server 2016 and Server 2016 isn't there. And again, using unavailable features. We are a little bit smaller than Azure, and so we follow behind them by a few months. So oftentimes, Azure's features that are released in Azure will take some time to come to Azure Stack. So you want to make sure that you're able to target both systems. We actually have a repository on GitHub, the tools repository, that has a template validator and that will check to make sure that your Azure Stack, the ARM templates you're checking in to deploy, are compatible with the Azure Stack that you have. And of course, you can make this an automated part of your Visual Studio build pipeline. Some common design considerations. Some things that we're going to get soon, but we don't have yet. Managed disks. That's something that we do get a lot of requests for. We have nothing to announce at this time, but we are working on it. It's on the backlog, I promise. You want to make sure that you're using discrete disks when you're deploying to Azure Stack. Auto scale for VM scale sets doesn't really exist yet. We're working on implementing that as well. As Matt talked about, multiple fault domains, application gateway layer 7 routing, point-to-site VPN, and Azure file support, so SMB share support. Again, we're working on bringing those in. But just some things you should think about when you're designing for these cases. For your ARM templates, use dynamic endpoints, parameterize your locations. If you look through, let me just show this real quick. So if you look at the swarm template that I showed you earlier, we'll take a little bit of a deeper look. If you look, it says something like VM name, resource group.location. That's parameterized, so I don't have to worry about picking the right region name, West US, West US 2, whatever you've named your Azure Stack instance to be. You can name it Seattle, my basement, whatever. But this way, it just gets it automatically and allows you to run it through. We also make sure that we have sizes that are available on Azure Stack. Azure Stack contains the A-size VMs, D, DS, DV2, and DSV2. Except for the DS15, the very largest sizes. And we're adding more, we'll be adding more, but just this way you're making sure that you're not deploying something that you can't possibly deploy. And if you notice, of course, all of these here have an API version. Sometimes API versions, we again are a little bit behind Azure, so we have some API versions that we have a little bit of lag in the API versions. If you use, again, the template check and the template validator, it will, on our tools repository, it will check it automatically for you.
One more thing to add there, though, is like today we're using API versions. Our build's a little bit behind. But as we roll out to GA, what we're going to be using is something called profiles. And you'll hear a little bit about them if you go to Ricardo's sessions on the Azure Stack team as well. But specifically what we're trying to do is a profile for all the API versions across clouds. And so what that means is that Azure Stack itself will have an API profile that allows you to kind of figure out which API versions are compatible with that instance of Azure Stack. And it's just a helpful way to kind of have, hey, the template is in this profile, so all the API versions that follow will be API versions that are part of that profile. So anyway, it's a cool tool that we're trying to roll out so that we can have even more consistency between Azure and Azure Stack.
All right. So again, for deployment, use parameter files. If you notice in Visual Studio, we have a parameter file for every single deployment here. .parameters.json. It's very simple. It's how we pass in our environment variables. And this allows you to customize deployments per location. And again, this is just as you can use this just as you can use regular code. It's text. It can be checked in, versioned. What we often do is for our different environments, we have different parameter files. And when we run automated deployments, we say Visual Studio, select this deployment for Azure, this one for Azure Stack, and this one for the second Azure Stack. This way, that again, all of our deployments are identical and kept in sync. Use Visual Studio for deployment. Visual Studio has a lot of great tooling that allows you to deploy to Azure Stack. Things like Cloud Explorer have all been upgraded to work with Azure Stack. And of course, use service principles like we demonstrated earlier to make sure that you're not giving away the keys to the kingdom with your actual credentials. And use hosted agents that have a personal access token that you can RBAC and make sure that your resources only have access to what they need to deploy your application. Yeah, going back. I just wanted to cover what was a Visual Studio. So yeah, again, Azure Stack Tools, it's a repository. We have a great PowerShell experience now. We have, again, API profiles that allow you to, again, switch between Azure and Azure Stack with ease. And yeah, that's pretty much what we kind of came up with as we were developing this app. We'll go ahead and take questions now. And of course, if you have feedback, if you'd like to provide feedback directly to us, even if it's just to say, I really hate this and I wish you'd stop, we'll be sad about it, but you go into that, you can sign up for a research study, that URL.
If you guys have questions, just step up to the mic just so we can get them on the stream. That'd be great. Hopefully we kept you somewhat entertained with this stuff. I know it's kind of complicated with some of the data science stuff, so thanks for bearing with me. But I think it's important as a skill set, especially as we move into more of a DevOps world, that we kind of understand the applications that are going on our platforms a bit more, right? And so Azure Stack is a platform, and so deploying that platform doesn't necessarily give value into the business inherent of itself, but it's really about what it brings to the applications that really deliver that value. So sorry for kind of boring you maybe a little bit with going into the depth there, but I think it is important to kind of say, hey, what is the actual application that this is actually going on our platform, and how does that application bring value to our business?
Of course, we hope we've given you some good tips on how to get started with DevOps, how to dip your toe in, or how to just go full force. We've showed you how Visual Studio has been upgraded to work with Azure Stack, how you can get started today. And of course, there's actually a site on Azure that lets you select different DevOps tools and tell you how they interact. Yeah, I think it's azure.com/trydevops or something similar. Of course. Are there any questions?
No questions at all?
All right. We were clearly.
All right, cool. If you guys have any Azure Stack questions in general, feel free to field them to us, and we can redirect as necessary. Business model, hardware, that kind of stuff. We'll kind of get you in touch with the right people to handle that bit. But otherwise, enjoy the rest of the sessions at Ignite. I know we have a couple more Azure Stack sessions, so if you guys want to.
Ricardo's at 9 a.m. tomorrow on developing hybrid applications. It's going to be a more in-depth look into those hybrid patterns that we were talking about.
Yeah, if you go one
and then one more. It's a very long list. We understand. Just a few.
Just a few. Yeah. So anyway, thank you so much for coming.
Yeah. Of course, we'd appreciate your feedback.